next topic we're going to see is Cramer's rule. Actually, this rule is used to solve the simultaneous equations. So now here let's take two equations and two different variables. Two equations and two different variables. And this rule is basically used to solve the determinants. Actually, if we have the two equations like a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So these are the two equations and x and y are two different variables. So basically, generally, if we have two equations and two variables, how we will solve? We solve by just using the elimination method. So we'll do that first. So first, to eliminate y, we will multiply the y coefficients, right? So the first equation becomes a1x will. So the first equation, this is the second equation. So the first equation gets multiplied with the v2. So it becomes a1b2x plus b1b2y is equal to c1b2. And second equation gets multiplied with the b1. So here it becomes a2b1x plus b1b2y and c2b1. Similarly, to eliminate x, we'll multiply the two equations with its coefficients. So the first equation get multiplied with a2 and here it becomes a1a2x plus b1a2y is equal to c1a2. And second equation gets multiplied with a1. So this becomes a1a2x plus a1b2y is equal to a1c2. Now let's eliminate it by subtracting. So this gets eliminated and similarly here x gets eliminated. Now what's the remaining part over here? So here when you take x common, it becomes a1b2 minus a2b1 into x is equal to c1b2 minus c2b1. And here it becomes b1a2 minus a1b2, take y common, and on the right hand side c1a2 minus a1c2. So I'm just taking minus common from this so that it becomes a1b2 minus b1a2 into y. Here also I'm taking minus out common, a1c2 minus a2c1. Now if you observe, this term can be written in terms of determinant. How? a1, a2, b1, b2, right? Or we can also write a2 over here and b1 over here. So you can cross verify it by multiplying a1 b2 minus a2 b1 into x, and this can be written as c1 c2 b1 b2. Cross verify it, c1 b2 minus c2 b1. Similarly here it's the same thing. So a1 a2 b1 b2 into y is equal to a1 a2 c1 c2. Now here what did the Cramer say is, instead of doing all this multiplication, subtraction and all, just find the determinants individually. Here what are a1, a2, b1, b2? It's just nothing but the coefficients of x and coefficients of y in two equations. So here we'll get assume delta as a1, b1, a2, b2 and delta x. What is meant by delta x is, this is called as delta x. Why? Here x coefficients are get eliminated and instead of that we got constants, those are c1 and c2. So it is called as delta x, and this is called as delta y. Why? Because instead of y coefficients, those are b1 and b2, will get the constants over here. So it is called as delta y. So from these two equations we can finally write as delta into x is equal to delta x, that is this, and from this equation we can write it as delta into y is equal to delta y. So finally we're gonna get x is equal to delta x upon delta and y is equal to delta y upon delta. So when you have equations, two simultaneous equations, you can find the variables by just finding the determinant respectively. Instead of doing the elimination method, you can use the determinant over here. So let's solve few questions so that you'll get a clear idea on this. Here, when we have two equations, we will get three different cases. Those are case 1, case 2 and case 3. Case 1 is when, that is, we have a unique solution. So what happens at the time of unique solution? Two lines will intersect at a single point and gives a unique point, that is called as a unique solution. Here the slopes of the two equations are not equal. So therefore a1 upon a2 is not equal to b1 upon b2. So when you do the cross multiplication, you will get a1 b2 not equal to a2 b1, which is nothing but a1 b2 minus a2 b1 not equal to 0. This we have just seen that a1 a2 b1 b2 is not equal to 0, which is nothing but delta is not equal to 0. So this is the final condition you need to remember. So when we have a unique solution, the delta is not equal to 0. Okay. Now coming to the case 2. Case 2 is when we have a no solution. So when we'll have a no solution? When two lines are parallel. So at that time the slopes will be equal, but these slopes are not equal to constants. So from here we'll get again three cases. That is a1 a2 equal to b1 b2. Next a1 a2 is not equal to c1 c2. Next b1 b2 is not equal to c1 c2. Here when you do, you will get delta equal to 0. Here when you simplify, you will get delta x is not equal to 0. Here when you simplify, like similar to this, you will get delta y not equal to 0. So basically you need to remember that when you have a no solution case, delta will be equal to 0, but delta x and delta y will not be equal to 0. Next, case 3. Case 3 is when we have infinitely many solutions. So when we'll get infinite solutions? When two lines are coplanar. On the same line we have so many points. So at that time slopes are equal and they are also equal to the constants. So again here you have three different cases. That is a1 a2 equal to b1 b2, a1 a2 equal to c1 by c2. Next b1 by b2 is equal to c1 upon c2. Again from here 3 will get, that is delta equal to 0, delta x is also equal to 0 and delta y is also equal to 0. So when we have an infinite many solution case, all the deltas, that is delta, delta x, delta y will be equal to 0. So these are the three important cases you need to remember when we have a two equations. That is, case 1 is unique solution and here delta will not be equal to 0. And case 2 and case 3, that is for no solution and for infinite solution, we have delta will be equal to 0. But what is changing? Delta x and delta y. In no solution case, delta x and delta y are not equal to 0, but in infinite solution case delta x and delta y are equal to 0. In this question, two equations are given to you and you need to solve this equation using the Cramer's rule. So first, let's frame this a linear equation using the substitution method. So assume 1 by x plus 5 as some variable p and 1 upon y plus 7 as some variable q. So when you do this, from this first equation we can get it as 4p plus 3q is equal to minus 1, and from this second equation we can write it as 6p minus 6q is equal to minus 5. So these are the two linear equations, and first let's solve the p and q variables, and according to that x and y variables we can find it. So this is the first equation and this is the second equation. So first we need to find three things over here. Delta, that is nothing but, just now we have discussed, delta is nothing but the coefficients of the variables, right? a1, a2, b1, b2. So according to this equations, a1 is 4, a2 is 6, 4 and 6, b1 is, so let us write it over here for the clear understanding. So a1 is 4, a2 is 6, b1 is 3, b2 is minus 6, c1 is minus 1 and c2 is minus 5. So just substitute the values over here. So a1, a2 we have written, b1, b2 is 3, minus 6. So when you calculate the determinant minus 24 minus 18, you'll get minus 42 over here. Next we need to find the delta p, because in this equations p and q are the variables. So instead of finding delta x and delta y, we need to first find out delta p and delta q. So delta p is nothing but, in the Cramer's rule we have seen, delta x is written as c1, c2, b1, b2. I mean, instead of the coefficients of x, constants have come. Similarly, here also, instead of coefficients of p, the constants will come. That is minus 1 and minus 5. b1, b2 remain as it is, that is 3 and minus 6. Similarly, for here, a1, a2 will remain as it is. Instead of coefficients of q, constants will come. So when you calculate this, 6 plus 18, which is 21. Here minus 20 plus 18 is minus 14. So these are the delta values we got. So first let us find the variables. So that is p is nothing but delta p upon delta. So delta p is 21 upon minus 42 is nothing but minus half. Next q is delta q upon delta. So that is minus 14 upon minus 42, which is nothing but 1 upon 3. But in the question we need to find the values of x and y, not p and q. So just put the values over here. 1 upon x plus 5 is nothing but p. What is p? Minus half. So here x plus 5 will be minus 2 and x will be minus 7. Now next 1 upon y plus 7 is q. Q is nothing but 1 upon 3. Y plus 7 is 3. So y is nothing but minus 4. So therefore the values of x and y are, x is minus 7 and y is minus 4. So these are the values of x and y for this required equations. Here you need to know few basic terms, that is consistent and inconsistent system of equations. So basically consistent is when we have a solution. So solution exists. And here we have two different cases. Just now we have seen. That is when we have a unique solution or when we have a infinitely many solutions. And coming to the inconsistent, here solution doesn't exist. Here there is only one case, that is when we have a no solution case. So consistent is the term we will use either when we have unique solution or infinitely many solution. Inconsistent word will use when we have a no solution. So just please remember this, because in question these terms are gonna use and they frame the questions by using these terms. So yeah.